Welcome viewers to the SD online classes. This is class 10 MBSc Physics chapter 2, the human eye and the colorful world. We have finished most of the things. Now we are at the end. This is atmospheric refraction. We are studying some physical applications of what we have done till now. In the atmosphere, how the refraction of light happens, let's try to understand. What is atmosphere first? Atmosphere is a very general thing that we see every day, observed around us. The great ocean of air around us. All this, where you are breathing from starting to there in the sky, everything. All that is atmosphere. It consists of what? It has many layers and layers of one layer above it, like this nitrogen, oxygen, all this, everything is there, okay, carbon dioxide, all. So colorless gases are there. You cannot say, all together we call air, and that is atmosphere. Air near the earth is denser. When it is near the earth, the lower air is denser, heavier. But as we go higher, the air is less denser, less heavier. Okay, very important this one. So when the light comes from the sun and comes to us, to the earth, okay, when the light is coming from the sun, okay, to the earth where we are standing here, what happens? It has to pass through these layers. Okay, so what happens in the layers? This is light, this is rarer medium, this is denser medium, so it will have to bend here, it will bend here. Okay, so we will find the light coming from here to here is not coming in straight line, it will bend. Why? What is the reason? Because it will act like a lens, or it can act like a prism also, you can understand. Okay, so because of the refraction happening here in each layer of air, this bending of light is happening. So that is called atmospheric refraction. So easy. So let's write what is refraction. So this will be our definition. The refraction of light due to the atmospheric layers. The refraction of light due to the layers, these layers, atmosphere having layers of air of different optical density. Okay, you know, I said heavy air, less heavy air. What is ultimately that is optical density. Okay, the refractive index is more, refractive index is less in the rarer one. It's called the atmospheric refraction. The atmospheric refraction is when this happens, bending of light happens, that is called atmospheric, because of atmospheric refraction. Okay, now there are physical applications also. Example, okay, first is apparent height and twinkling of star can be explained using this atmospheric refraction. Now suppose you are on the surface of the earth, standing here on the night. Okay, this is earth and you are standing here and you are trying to look at the star. This is suppose the star in the sky, and from the star what happens? The light comes in this way. Why not straight line? Because here are atmosphere and atmosphere, and every atmospheric layer will act like a lens, and that lens will make the light bend. But we can only see straight. So what we will see is, we will see that this is coming from somewhere here. We will think that it is here, but actually it is somewhere else here. So this is called apparent position of the star, that we are actually seeing it here, but actually it is somewhere else. Okay, another thing also happens, twinkling of star. Why it happens? Because these layers of atmosphere, okay, all these layers of atmosphere layers, they are also not permanent. Okay, they change, keep on changing, because sometimes it is cold, sometimes it is dusty, sometimes night time it is different. Everything it happens in the atmosphere. Then what will happen? These layers are going to be sometime thick, sometime less, sometime denser, sometime lighter. Then what will happen? Even this is also not permanent. It will go, sometime you will find visible, sometime slightly less visible. So this is called twinkling of star. Everything happening because of the atmospheric refraction, it happens. Okay, this you have to be able to write in your own words with a small diagram. Okay, so as you go down, refractive index increases. Why? Density, optical density increases. Here it is less, here it is more. Okay, here the optical refractive index is very less, the refractive index is high here. So this is, you have to explain in your words. You are going to read in your textbook page number 60 and you will write in your own words with this diagram. Okay, diagram also is given, figure 2.13, right? Another important phenomena is planets do not twinkle. Because I have told you that stars are twinkling and they are moving from one place to other, as if we see it is moving, actually not moving, but we see. So why not planets do this? Because when you compare to the Earth and the planet distance, that is very less when compared to Earth and star. I don't mean that Earth and planets are near, but Earth and star are very, very far. So that is why if it is far, the angle made on the Earth, okay, if it is very, very far, then the angle made, if it is very, very far, this angle made will be very small. Can you see this angle? Very, very small. But if something is near, the angle made will be bigger. This angle will be bigger. So that is the difference. If that angle is bigger, then you will not see too many changes there. Here you will find it is going here and here very easily because of this angle very small. Slightly also missing means it will go here and there. So that is why you will see twinkling also, and planets are not happening here. In case of planet, what you have seen in star, in planets it is not visible. Okay, it is easy, written in your textbook, well written, page number 60. The second example is that one. You can read and you can. The third one is more important, that we will do. Why? The advanced sunrise. What is the meaning of advanced sunrise and delayed sunset? Meaning is that whenever there is sunrise in the morning, we will see the sun very early, even before the sun actually came, and the sun is sunset in the evening. Even after the sunset also, for some time it remains in the visible range. We can see for some time. Why this happens? Quickly coming early and going late. These two things are also explainable in terms of refraction. We will do that. Okay. Now the third one, this is the most important one, the advanced sunset and delayed sunset. Why we see? Suppose this is the sun, this is the earth, you are standing here, or anything who is standing here. So actually the sun is coming from here, okay, in the morning. It is like this. And suppose you are in India, still it is not the morning, okay. It is very early morning, maybe at 3, it is at 4:30 p.m. like that, 4:30 a.m. like that, okay, or 5 a.m. like that, early morning, when the sun is about to rise. And after that, what you will see is this light coming from here. Here there is all atmosphere here. This is all atmosphere, air. So what will happen is this light will reach here, and okay, when you will see the light just here, suppose just in the morning, okay, so you will find that because of the refraction, this person here is going to see as if the sun is somewhere here. Okay, why this is happening? Here there is atmospheric refraction happening and the light is bending, and you will see the refracted ray, different density. Here there are a lot of layers and layers which are continuously bending it towards the normal. Now the observer will not see this here, it will see only straight here, somewhere here. So he will find that sun has already here, but actually the sun is yet to rise in the morning. This is called advanced sunset. Advanced means earlier than the actual. And also similarly in the evening also, this sun will go here, here it will go, okay, here it is there. Again the same thing will happen. This is the actual one. You should not see the sun in actual, but you will still see, because of the refraction here, the sun will appear somewhere here. So that means this is the virtual. Dotted line means virtual, not the real one. So this is called advanced sunset, sunrise, and this is delayed sunset, both happening due to atmospheric refraction. Okay, from refraction these are the explanations. Okay, thank you. This is all.